We talked in topic 1.3 about limits that don't exist because of unbounded nature. In other words, as we were approaching a value, the function was approaching infinity or the function was approaching negative infinity. And we can watch that play out on a table as well. So let's consider a function f of x equal to 3 over 2x minus 12. Now then, what we can look at here, if I've got 2x minus 12 in the denominator, obviously that can't equal 0. And so that means that f of 6 is undefined because the value 6 gives me 0 in the denominator. And as you should suspect by now with limits, that means I really am curious about what's happening as I approach 6. What is the limit as x approaches 6 of this function? Again, a function maybe that we don't know what it looks like just off the top of our heads. Depending on how comfortable you are with rational functions, you may or may not have at least an idea of what's happening here. But let's go ahead and construct another table looking at x and f of x. And very similar to what we've done so far in this lesson, we'll start off with 5.9. And then we'll make our way to 5.99. And then make our way to 5.999. Now then, I do like throwing the value on the table because I think it's worth knowing what f of 6 is. And for this particular example, f of 6 is undefined. But I think it's worth having on the table, even though this particular column has nothing to do with what we end up looking at when we look at the limit. But I like having it on the table. So we also want to look at 6.001, 6.01, and then lastly we want to look and see what happens at 6.1. So again, this is something where we're going to substitute this in. It probably would help if we have a calculator, or if you're like me, if you already have the example worked out here next to you. But if I take 5.9 and I substitute it into this function, the value that I get is negative 15. If I take 5.99 and substitute it into the function, the value that I get is negative 150. And if I take 5.99 and substitute it in, the value I get is negative 1500. And if you take now and look at what is happening to this graph, we want to describe what's happening to this function as I approach 6 from below. So as x is approaching 6 from the left side here, take a look at what's happening to my function. Negative 15, negative 150, negative 1500. In fact, I could keep throwing 9s on this and you'd probably have a pretty good idea of what would be happening to these function values just by looking at it. But what's happening here is this is growing unboundedly large in a negative direction. And so I can say that the limit as x is approaching 6 from the left, the function is approaching negative infinity. Remember, this implies that the limit itself doesn't exist, and we're using this statement right here to describe that as I get close to 6 from the left, the function is headed towards negative infinity. All right, let's plug in some of these values over here. 6.1, if I substitute it in, I get positive 15. 6.01, I end up with positive 150. And then 6.001, I get positive 1500. And I get a very similar kind of behavior. So if I say the limit as x approaches 6 from above of my function f of x, as I'm approaching 6 from the right, my function values are growing unboundedly large, but this time in a positive way. So I can say that that's headed towards positive infinity. Again, that implies the limit does not exist. And because I'm not headed to the same place, from the left I'm approaching negative infinity, but from the right I'm approaching positive infinity. That means very plainly the limit as x approaches 6 of this particular function does not exist. So this idea that a limit might not exist because the function is unbounded can also play itself out on a table, and it would look something very similar to this.